Hello everyone, my name is Bill Borsari. I'm the lead SE for Datera. I'm going to take over the system here. We have two demonstrations today. The first one is going to be focusing on the Docker integration. We'll show a little bit of the product, show Docker, some of our template system, as well as our quality of service capability. The second demonstration will focus on the OpenStack system. So I'm going to start by logging into the Datera web user interface. Make this a little larger. We try to design the interface to be as simple as possible. A lot of the customers we work with are very large scale and are interested in integrating into their existing infrastructures for monitoring, metering, measuring. So the Datera interface is really designed around system information, simple provisioning, and status of the cluster. The design is around these cards or pages. Here you can see a capacity one, initiators, provision instance, so forth. We have graphs that report performance. This would be at the cluster level. And then the current performance. We'll be spinning up some I/O as part of the demonstration. What I'm going to do now is open the menu and transition to the Storage Node tab. As we talk about Datera being a scale-out system, what we're looking at here is a cluster that we put together with a couple of head nodes for a POC for a large customer. So we borrowed it for this event. We have 3 nodes in this environment. These are what we call the DT5005. As Mark alluded, we have 2 SKUs today that are a reference BOM, if you will, that we qualify toward. As we work with customers, they present the hardware they want to use, and we work with them to qualify it. At a high level, it's pretty simplistic. You can see the various aspects and their state. This is all recorded internally at the cluster level. We have 12 hard drives. It's a 2U chassis using Supermicro components. And then this particular system has 2 NVMe flash drives. So we do have a tiered architecture. And Raghu will talk more about that when he gets into the design. A couple of boot drives, a couple of network interfaces. We do ship with 1 gig management. The base technology has a pair of 10 gig interfaces and a pair of 40 gigs. The design is exceedingly flexible, which is good and bad. On the good side, we can meet our customers' requirements, whether it be a single 40, a single 10, or 4 interfaces with the traffic distributed, and that can all be addressed during the cluster creation time. So the system presents storage, obviously. We have a couple of concepts which are a little different than traditional systems. We talk about application instances, storage instances, and then, of course, LUNs or volumes. If we look at creating storage in a traditional array system, in traditional IT, typically what happens is a request is made through some sort of system, a ticketing system that the customer has for their own environment. That triggers a workflow for a storage team to go figure out where does it need to attach, how much is it worth, what array does it get put on, what network segmentation. There's a lot of work on the back end. And as we know, that the purpose of cloud is self-service, to get to a more dynamic, agile infrastructure, and that old model doesn't apply. Just to draw the contrast, the Datera, we can stand up individual volumes using sort of that old method where I choose the name of the instance, I select the access control based on IQN, I can select what IP pools it might be coming from, set the volume parameters, and I could do this as a one-off request. The problem with this infrastructure is it provides, in some ways, too much visibility when you get into a self-service model. So what I'm going to do now is jump over to our Docker environment, which is running in the terminal window here.
So you talked about the certification you're doing. How long does it normally take if you want other hardware certified?
So it's going to depend how much it varies from the base design. Some people might want to get more flash, use different hard drives. It really comes down, maybe different processors. It comes down to a component by component level. Okay. So far, most of our customers have looked at our presentation in terms of the network bandwidth, the amount of flash, the amount of disk, and have pretty much agreed that that's all lines up. We use 12 hard drives. It gives us a little over 2 gigabytes a second of throughput, so we can do sequential reads and writes at line rate for the front end. Those kind of things have been taken into consideration.
And on the other hand, you'll be working on more certified hardware also, I guess.
Absolutely. I mean, our goal is to say yes. Whatever the customer wants to do, we want to say yes, but that comes with being successful as well.
Yeah.
And so right now, as Mark had mentioned, we certify, or we have a BOM based on the Supermicro hardware. We're looking at qualifying Dell and Cisco today. As our customers ask for other hardware, we'll work to support that. And Raghu, of course, wrote most of the self-describing engine and can talk about it in quite detail. So here we have a head node running Docker. There's currently no containers running. It does have the Datera Docker volume driver running. So using Docker commands, we can introspect this. There's currently no Docker images running, and there's no Datera volumes created. So I'm going to go ahead and create a volume for Docker. Just a little bit of a background on Docker if you're not familiar with it. Docker has seen a lot of success in development-driven environments where the use case is present code as quickly as possible to users. There was a Docker convention, DockerCon, or ContainerCon a couple months ago. Guys from like Yelp and so forth were presenting how they use containerization. A developer on their laptop can define a container, what the elements are. They can push that into their infrastructure. The infrastructure DevOps team can push that container to production very, very quickly without having to worry about kernel versions and whatnot that typically come from the virtualization environment. The majority of customers that we talk to are using containers with stateless applications. And if you look at the way the container infrastructures are designed, they tend to favor stateless today. We feel that the tipping point for containers in enterprise applications when you can onboard some of those stateful applications. And this is a long way of saying that in the Docker world, unlike a lot of other provisioning systems, I create the volume first, and then I take that volume and put a container, attach it to a container. And that's just how Docker is constructed. Other container systems might work slightly differently. So we'll give this a simple name, and then I'm going to start specifying the various parameters, such as the size of the container, in this case, the number of replicas of the container, of this volume to make inside the Datera system. So here we're typing the Docker command. And again, what I'm specifying, and the purpose of this is to show that I'm telling aspects of this container deployment around number of replica factors, which has an impact in the cluster consumption and other aspects. And I'm also providing the size of the container. So when we run this command, we will produce a single volume for the application. I don't know what I didn't specify. What Datera has done differently is we have this concept of templates. And Mark was alluding to this in terms of policies. You can effectively think of a template as a collection of policies. And so instead of instantiating storage based on the desires of the developer, you can actually instantiate storage based on a particular application. In this demonstration, the application is MongoDB. So instead of saying, give me storage that's 3 replica and 100 terabytes, and expect anybody who is provisioning to know that for their end goal in a self-service environment, we can do a provisioning based on the application itself. And so now, if someone needed to provision, Enrique, you can provision Mongo by saying, use the Mongo template. And all of the parameters that are encoded within that template would then be provisioned in the system.
Do you have a mechanism to check or to browse all the volume to understand what you have effectively deployed? So I have 100 MongoDB
yeah, so it goes
volumes or whatever.
Exactly, and it goes a little bit beyond that. So when we deploy the Mongo, it actually there's a relationship, and Raghu will talk much stronger about this, between that deployment and the template itself. So there's a couple ways you can do templates. One is unbound and the other is bound. We do bound templates. So within that Mongo instance, and to expand on that a little bit, Mongo for dev, Mongo for prod, Mongo for you, me, whatever. When you specify that template, all those instances are now bound to that particular template. And I can operate against those instances at that template level. So what we can show is I can create a number of different instances. We'll watch the performance increase here in just a second. And then what ends up happening is the template itself is going to have those 10 Mongo instances bound to that template. If I wanted to alter the snapshot policy, I change the policy of the template, that'll ripple through the instances. If I want to modify the QoS, I change it at the template level. So you can certainly use the traditional method of creating an individual volume, but if you think about it scale, if I wanted to go back and change all of the MySQL volumes, I need to know that's what they were. In our architecture, in our model, what's fundamentally different is if I know that there are 15 MySQL templates, I can modify those templates, and now I've touched every MySQL deployment.
And you also change the template. So I create a volume from a template, but at a certain point I decide that I need a different template for that volume, so a different policy. But I don't want to stop the application.
Yes, the right way to do that is that you just make from bound to unbound template, and then you can change the policy on that.
Okay.
Oh, never mind. No, you're good.
So there's a concept of a bound template and unbound template. The bound template always follows the parent template, and if you want to change it to a new template, you can reprovision to a new template by making it unbound and overriding the policy, basically.
So in this demonstration, I created a container. The container runs FIO. It's a 16K, 100% read workload, just for some simple IO. And if we see in the demonstration now, the container is running, and I'll flip
Are
back.
the containers running on the storage device server?
No, this would be
They're
the
running
head-
on separate servers.
Separate server. So the Datera comes as an appliance. It's a
Right.
software-defined storage appliance. So we take over the hardware. We would be a separate tier, and then you'd have your application and hosts above that. So here you can see we're doing about 400 megabytes a second, about 30,000 IOPS from one container running on one head node. Thank you, Ray. And then what I'll go ahead and do is spin up some additional containers. So it's the same container image with the same FIO workload. What happens on the Datera side is that would be going to another volume within that same template, although at this point that's not as important. And here you can see the IO workload has increased. So we'll go ahead and add another one.
So, Bill, are you creating LUNs for every single one of those volumes that you're creating in Docker?
Yeah, so the Docker driver, during the creation process, will instantiate storage on the Datera. So it exists, and then you attach the container to the storage. And so we're
Yeah.
attaching containers.
But you're effectively creating an iSCSI LUN for each one?
Yes.
And attaching it to the host that's running Docker?
Yes, the attach process is the driver's job.
Yeah. So when you do that, what happens if you want to move that container elsewhere?
So that's where Docker and Swarm come into play. And you hit the nail on the head. This is one of the challenges in containerized workloads today. How do I move it? And so Kubernetes has its system for doing this. Docker and Swarm can work together. Our driver works with the Swarm infrastructure. So if I had n number of hosts, Swarm is the orchestration point. It would be making that attach. And if that volume is needed on another container, it would make that attach for that container.
Right. So as part of that, you must have to set up your security somehow. So you must have some security for that LUN mapping at some point to the host.
Yeah, security, with iSCSI, it's ACL based. So you can migrate the driver when it goes to do the attach, can inspect that local host, understand the IQN, insert the IQN into the LUN and make it available.
Okay, so when you flip that to another host, does it do all of the security modifications to make that work as well?
Yes.
Yes.
So the Docker driver, official Docker driver that we're going to have is that we certified today basically has that property that on an attach, it reprograms the instance, and so you get a new ACL for that access.
Okay, and how do you make sure that that's secure, that somebody else, like I couldn't just power up a server on your network, attach?
And that's where the next level of credentials and security is coming in. Basically.
Okay, all right.
Yeah.
So that's,
I mean,
that's a work in progress.
It's a work in progress, but this is the best that we could do with the infrastructure of the Docker we
I know,
have.
it's not-
And there's so much activity going on in security and Docker.
Not fully there.
It's not fully there.
So, yeah.
Yeah, I mean, certainly accessing the Datera REST API requires a token. That's security. That's a security
So
aspect.
that's already secure in that sense. Okay.
Yes. So I think
And the Docker driver, there's a client version of that and a storage version of that?
no. So what happens is you would deploy the Docker driver and step back on Docker. Persistence in the container world is something that we're working with them to develop. It's a growing aspect. You run the Datera Docker driver on each of the hosts that would have Docker. And it's doing the activity of creating the LUN, formatting the LUN, mounting the LUN, presenting it to Docker so that it can use it as part of its operation.
Talking through your Datera API?
Exactly. The driver is the communication point between Docker and then to the Datera.
And that's part of the Linux kernel, is that what you said, or?
The Docker infrastructure is going to be on the host. From that perspective, it's any orchestration piece. Here we're just simply showing the integration with the Docker technology. So I'm not quite sure I understood the question.
Yeah, I'm trying to, so you've got some client software, I'm just trying to understand what sort of distribution that ends up being. Is it part of an operating system? Is it part of Docker,
It'd be part
mechanism?
Yeah, it'd be part of the Docker infrastructure. It's a written in Go. Docker's written in Go. It interacts. Think of OpenStack Cinder, where you have a driver per array.
Right.
That infrastructure still, in the way Docker is created, we'd run the driver on every single system as opposed to a centralized system today. And we're speaking about Docker. The other systems out there, CoreOS, Rancher, might do things a little bit different. But for Docker specifically, we'd run that driver local.
Okay.
As the orchestration.
Yeah, it gets distributed as a plugin infrastructure, basically. And what we have done is that we have gotten the driver completely certified by the Docker team itself. And so we will be on their website in terms of as a technology partner for storage, persistent storage.
So there's a question from the Twitters. iSCSI mapping, what authentication method is used? IQN, CHAP?
Yeah, we have since we are based off Linux LIO subsystem, so we basically use CHAP, MCHAP, and IQNs, all the three.
That's all configurable as part of the policy as well for the LUN. So what I want to show in this portion of the demonstration is altering the QoS. A few seconds ago, we were doing about a gigabyte a second with 3 containers running a 16K random read workload. So what I'm going to do is navigate to the MongoDB template. As you can see, we've got our 10 provisioned instances presented. They're bound to this template. We're using 3 of them. I'm going to go into the storage instance tab, and I'm going to change the bandwidth here to 300 megabytes a second. And then that's going to step it down a little bit to about 900 megs. And then I realized I was a little too fast. So we're going to change it again and change it to about 1,000 IOPS. One thing I'll point out is our latency at this stage is still about half a millisecond for gigabyte a second. It's not too bad to a single host. When we change the template and change our performance profile to IOPS-based profile, the latency will go up because we're back pressuring the application, which also allows us to do, in a scale-out environment, better sharing between applications. And now we're looking at 3,000 IOPS being generated by our containers. Now, all of the instances that are bound to that template will have inherited those properties. So if I inspect them individually, we would see that same template level policy have impacted the volume level policy.
So, in terms of the way you design this, is this a single cluster that's expected to sit in a single data center? Is that the architecture? Yes.
So the reason I'm hesitating on the answer is that the types of deployments that we're working on are like 1,000 node Hadoop deployment. So when you get to those kind of scales, you don't usually use singles. In that, if you're going to do 1,000 node OpenStack, you're actually going to subdivide that. And so within the Datera context, I might have 3 or 4 or 5 Datera systems presenting for certain aspects of it.
I guess I was asking really if you're going to stretch it across data centers.
At this point in time, we are not doing any stretch thing. The only thing that we are planning to do is doing a DR and replication to the remote data center, and then do a global failover. That's coming up in the
Do you think you could do that in the architecture, though? Could you have multiple access points for the same data in different locations and allow you to have more of a mobility feature?
It depends on the latency, right? At the end of the day, it's a physical limitation. You can't solve the instance problem, so you kind of figure out what the latencies are, and if it's going to be within the context of 50 miles or whatever the latency dictates, we could potentially do that.
Yeah, if you're talking Jersey to Manhattan, then perhaps I could get away with that. 14 miles, another customer mentioned. Yeah, we could probably build the same cluster, and getting into the policy piece, define a policy that says 2 copies here, 1 there, 2 whatever they need to do. That's the power of the architecture, is the policy. So that concludes the demonstration for Docker and the quality of service. Any other questions on this, or Raghu can really
I think we
Finalize
might need to take this offline because it might divert for about an hour into Docker. But obviously, what you're showing is very much a volume presented that's being used to not boot the operating system, but it's effectively the operating system of the container, or at least looks like that.
Yes, sir.
Have you thought about how you would do it if you wanted to attach data to that container through a different route? So if you wanted to actually have the data elsewhere as a LUN and map to it more directly, not through the Docker API, if you like, would that actually make any sense?
So to be fair, the root file system in the Docker context is an overlay.
Yeah.
And it's separated from the data drive. So in the Docker world, when I attach a volume, it's not boot. It is just a separate different slash.
Yeah.
In this case, /FIO. And what the Docker driver does and what Swarm allows, the portability of that mount point between different containers. So I could clone that. I could mount one to multiple places using read-only, that kind of thing. So I think your question makes sense, but that's kind of how it works today in that I create that iSCSI volume, and generically, Datera or whoever, present that into the Docker infrastructure. The Docker then consumes that as a mount point, and then the application can be instructed to write data to that, which, as I did in the FIO example here. And then when that container dies, is terminated, its work is over, you have that persistence piece. It stays behind, and then it can be attached to another container.
Or a different orchestration engine.
Yeah, I was thinking more about, could you, if you wanted to share data between multiple containers, that's not really something we do today, is it?
Yeah, we don't do it today because at the end of the day, it's an application consistency model, basically.
Yes.
So the applications have to be cluster aware
Absolutely.
into containers. And if they're capable of doing it, the storage platform itself does allow multiple active nodes to participate in I/O, basically. So it does not preclude from a storage platform perspective. It's more the application perspective of clustering, and this is the same thing with OpenStack too. Basically, when you do multi-host attach for a given volume, they'll leave it to the applications to give the consistency model, and they let the Cinder and everything else be what it is, basically.
Yeah. Okay.
So you showed the CLI. Is there like a RESTful interface to this as well?
There is. We'll cover that in the OpenStack demo.
Okay.
Well, we'll get to the REST piece.
So the second demo we're going to do is more about the programmability and the API aspects of the product, basically. So.